4 basic kinds of reactions. And so all reactions are one of the 4. Okay, so this is one way, it's just the basic way. And then there's another way of looking at what we call specific or special cases of reactions. So the basic kinds, the first one's called a combination. And so this has the form of 2 components joined together to be a together component. Let me give an example. An example would be the reaction I wrote. Hydrogen combines with oxygen to make water. Now it's just things coming together. Here I have coefficients. There's 2 hydrogens combining with 1 oxygen, but it's still a combination. Okay, so that's a basic kind. Question? Or okay, maybe that was just some feedback. I might have a microphone on my camera that's doubled with my headphones. Okay, anyway, the other one, second kind, is a decomposition. By the way, the combination, I don't know if this is important, sometimes called synthesis. Okay, decomposition is basically the opposite of combination. Something with 2 components splits apart into those components. Actually, this reaction's reversible. Water with electricity, if you have the correct voltage and some ions present, will separate into hydrogen and oxygen gas. That's a decomposition. There's many, many decompositions. That's just a very simple one. Okay, there's still 2 more. The third basic kind is a single replacement. Sometimes it's also called a single displacement. I think it's just semantics and it doesn't matter at all. But it's one thing with 1 component reacts with something that has 2 components, and 1 component leaves and the other one joins. So A joins with C and B gets left alone. So B is by itself and now we have A with C. A really good example would be a metal reacting with an acid. Zinc reacts with 2 hydrochloric acid to make zinc chloride and hydrogen gas. So the hydrogen is bumped and the zinc joins with the chlorine. Yeah, that's a single replacement. All right, is everyone on board? Is this okay? All right. The next kind, it's called a double displacement, or sometimes they call it double replacement. I always call it double displacement. But it's probably not that important. So double displacement has 2 things with 2 components. AC, oh, I did this backwards. I'm sorry. Let me do AB plus CD. And so if I consider A as the metal or the cation and B as the anion, then the A cation will go with the D anion, and the C cation will go with the B anion. And I will get, well, cation A with anion D and cation C with anion B. All right, so an example of that, like a precipitation reaction, silver nitrate plus sodium chloride goes to silver chloride plus sodium nitrate.
I have a question.
Go ahead.
Does it matter, like, if it was DA plus BC? Like, does it matter which one goes first?
Well, all I'm No, it doesn't. I wanted to do A, B, C, D, but the main idea is it's cation, anion plus cation, anion. So when they switch, I want to make sure that a cation is with an anion and a cation on the left, right? Because you don't write, you write, I mean, if you think about it, you write sodium chloride. What you don't write is chlorine sodium, right? You don't write that. So I can't just switch them. I have to be mindful of what's the cation and anion. That's just part of. So this is just the main thing is that you're doing this one correct, right? That's what
Okay.
really matters.